Hello, and welcome to another Developer Skill Sprint. My name is Brian Alexakis. I'm a Product Marketing Manager here at Embarcadero Technologies. Today we will be talking about how proximity awareness works with beacons. This is the last skill sprint for the 2015 Spring Series. We will be starting a new Developer Skill Sprint series in the near future. As proximity awareness is powered by beacons, this skill sprint will not currently work for Windows deployments. Currently, beacons are not supported for Windows 7, 8.1, or the technical preview of Windows 10. However, it is expected that with the full release of Windows 10, we will then have beacon support. So today, beacons do work with Android, iOS, and OS X devices, and the beacon component that I will be demonstrating is available for FMX projects, C++ projects, and Object Pascal. They work with RAD Studio, C++ Builder, Delphi, and AppMethod. There's also a RTL for the beacon available. I will not be getting into that for this demo, but I will have links to that information in the blog notes. Beacons are Bluetooth low energy devices. But unlike most Bluetooth devices, beacons do not pair with other Bluetooth compatible devices. On their own, beacons do not receive or process any data. All beacons do is chirp out data on a timed interval. With each chirp, the beacon will advertise a small amount of data, which consists of a GUID and a minor major value pair, as well as the device's power output. There are two beacon formats, iBeacon and AltBeacon. iBeacon is the Apple standard, while AltBeacon is an open source standard. For more information about these standards, I'll have links in the blog notes. Within the context of Embarcadero's beacon component and the RTL, an iBeacon is considered standard and the AltBeacon is considered alternative mode. But this distinction is really only important if your beacon only supports one beacon format. The beacon that we're going to use in today's demo supports both the iBeacon and AltBeacon formats. EM Microelectronic manufactures the EMBC01 beacon. This beacon features a rubberized, weatherproof enclosure and has accessories to adopt the beacon as a wall mount, a key fob, or as a wearable device. It can advertise in three different modes: short range up to 15 meters with a 100 millisecond chirp interval, a medium range up to 30 meters with a 500 millisecond chirp interval, or a long range which will go out to 75 meters with a 1 second chirp interval. The short range broadcast mode will effectively have a battery life of about 1.5 months. The medium range will last for about 7.5 months, and the long range will last for about a year. The range that you will want to choose for your beacon ultimately depends upon the application of that beacon. But for testing purposes, I recommend that you stick with the short range mode. The beacon has a push button which allows you to toggle between the different modes. And if you get this particular model, one trick that you can do to get it into the short range mode is that when you take the power supply out of it, which is basically a small battery, and you put that battery back in, it resets it into a mode where if you just toggle it once, it'll then start in the short range mode. Unlike other beacons, the UUID major and minor values are pre-programmed by the manufacturer. The major minor values are printed on the rubber covering. This is a security feature of this particular beacon, whereas other beacons are programmable, which basically means that in theory, anyone can change that data being stored on the beacon if it gets hacked. The T-Beacon component makes it really easy to add beacons to your application. There are two events we are concerned with for this demo: on beacon enter and on beacon proximity. On beacon enter will get triggered when a beacon becomes reachable. That is to say, when the listening device picks up a beacon signal regardless of what range that signal might be at. On beacon proximity gets triggered when a known beacon transitions from one proximity to another. This is determined by measuring in meters the distance from the device to the beacon, and the component takes care of that signal processing for you. There are four proximity thresholds: immediate, near, far, and away. We'll get into how those are defined shortly. Here on the right side of the slide, you can see the ways that you can call against the different proximity thresholds from code in both C++ and Object Pascal. And we're going to see that in code during the demo a little bit later. Proximity awareness only defines presence within a radius from a known position. This known position is defined by the given Android, iOS, or OX10 Bluetooth device. Proximity awareness does not provide a vector, nor does it provide positional information. So it's not really possible to tell which direction a beacon may be moving or where inside the zone a beacon is positioned at any given time. The only thing you can be sure of is how far a beacon is from the listening device, and then what proximity zone the beacon is in. Immediate range is less than half a meter from the listening device. Near proximity is between half a meter and 1.5 meters from the listening device. Far is greater than 1.5 meters from the listening device. And lastly, away is beyond detection range, and therefore the distance are indeterminate. Beacons can be stationary, while a device like a smartphone is tracked moving through the proximity regions, but it also works the other way around, which is how we're going to be presenting it for today's demo, in that a listening device, for example, a maker board like Odroid, which runs Android, could be in a fixed position, and it is assumed that what is tracked is actually wearing the beacon. Both of these approaches are valid and are used for different applications of beacons. Before we get to the demo, I wanted to just quickly talk about the Internet of Things and beacons, and how beacons can provide contextual data to an Internet of Things solution. So what exactly is, an Internet of Things solution? Or you put it another way, what makes the Internet of Things the Internet of Things? Well, it's more than just turning on a smart light with a phone, for example. IoT solutions really take meaning when more than one device or multiple data points are combined to provide contextual data. This data is gathered by various sensors and devices, and are generally collected and aggregated together within a system. So for example, if you take a beacon and add that to the smartphone and smart light concept, then that light could automatically turn on when the smartphone is able to detect the beacon within a certain range. In this context, adding the beacon allows personal identification and proximity within a system, which is used to determine whether or not the light should turn on without any action by the end user. The light just turns on automatically. This is kind of the magic behind the Internet of Things, and that the environment just kind of responds to your presence. So some other examples of how contextual data can be applied could be found on a solution on a farm or at home or even in a healthcare center. There really are a lot of opportunities here. Consider a farmer that wants to track his herd, or a smart car door that will, I'm sorry, a smart cat door that will only open when it detects a beacon attached to your cat's collar. This would effectively allow your cat to get into the house, but denying any other cat that doesn't have a beacon to get through that same door. In a geriatric care center, you might find patients that have things like dementia who should not leave the premise or exit through certain doors, else they could completely get lost in public. So, as a safety measure, you could take a beacon, put it onto each patient so that they effectively wear a beacon, and then place a listening device like an Android maker board or something else at certain exit points. And if any particular patient gets anywhere near that door, the door could automatically lock, or perhaps if they cross over a threshold, an internal alarm could go off, uh, which could help prevent patients from accidentally escaping from the care facility. So this is all really exciting stuff when you consider that the cost of all the hardware needed to implement these kinds of solutions is actually quite low. Um, Android maker boards, for example, go for about $100, and the beacons themselves go for about $6 or so each. So this makes it really cost effective to roll out large scale solutions that use beacons. Today's demo will open a smart door lock, and a smart light will turn green when the beacon crosses over the immediate proximity threshold. For this demo, I used my Nexus 5 phone, but you could just as easily use any device capable of understanding a beacon. Once the listening device determines that a beacon has crossed that immediate threshold, it will take a look at the minor value associated with that beacon, verify that it's a known value. In other words, it will verify that that minor value correlates to some individual. And if that value is known and verified, then the smart door will unlock, the light will turn green. And then when that beacon leaves the immediate threshold, the light will turn back to red and then re-engage the lock. Both smart devices are controlled over REST API. And for more information about how each device functions, I have some additional information in the blog, and I'm going to talk briefly about it during the demo as well. There's two demos that I want to show. The first is the expression of proximity awareness through light using the Philips Hue iris. So each zone, immediate, near, far, will be represented by a different color. Then after that, I will show how to look at just the immediate range, verify that it's a known minor value, and then turn around and change the color light to green and open the lock door. And when the beacon leaves that threshold, it will then turn the light red and close the door. Okay, let's take a quick look at the beacon component. If you can, as you can see here, the beacon has this monitorized regions. If I open this up, this will define the number of beacons that you want to add and keep track of within your application. Currently, I just have one beacon, and I am explicitly defining its major minor values. And lastly, the UUID. Well, the EM Micro beacons all share the same UUID. If I wanted to keep track of not just this in particular one, but all of them, I can change the major minors to -1, -1, and this will listen for all beacons instead of the one that I'm defining. Okay, so then we can take a look at the events. So as I mentioned earlier, there's two events we want to look at: on beacon enter and beacon proximity. Let's take a look at enter. So this basically just sets the initial state. Once the beacon is first discovered, this is the event that will get fired, and we do an initial update. We are actually just going to call the exact same function for each event. It's just that you have to remember that the beacon proximity only gets fired when that proximity threshold changes from one proximity to another. So if the beacon starts immediate, it won't actually get fired until the beacon transitions into another proximity, whether that's near or far. So by having this update proximity get called the moment that the beacon is discovered, we'll set the initial state. Then if we look at the actual update proximity function, essentially all we're doing is passing over the beacon, handle to the beacon, and then we take a look at the proximity property of that beacon. and just do a switch statement, and we're going to look and see which beacon proximity it matches. So if it's an intermediate, then we're going to trace out to the memo that we found a beacon with a particular minor value and that it's at the intermediate state. For intermediate range, we're going to set the hue iris to green. For the near phase, we'll set it to blue. Far will be red, and away will be purple. If we take a look at the set hue iris function, you can see that all that's happening here is that the REST request parameters are being updated according to the Philips Hue REST API. There's a XY command that you would pass a XY value into that is basically a XY color space, again defined by Hue. And I have more information about all this in the blog. And then essentially after that, there's a timer that just checks whether or not this value ever changes. And if it is changed, then it'll go ahead and execute that request and change the color of the light. So this is kind of nice to put it in a timer like this because sometimes the beacon events can happen a lot and it can flood the Hue bridge with REST requests. And so by tying it into a timer, it kind of just helps the bridge handle requests. So let's go ahead and take a look at what that demo looks like in action.
Okay, green, go. Okay.
Okay, here we have the next demo. It really is just an extension of the demo that I just showed, but we now have two sets of REST components, one for the Philips Hue iris, the other is for the smart door lock. For more details on how these REST components were created, look to the blog, and I link to additional learning resources that talk about how to set up these REST components. If we look at the code here, oh, actually, before you go into the code, I wanted to show the difference in the monitorized region, in that here, I have the same UUID, but I've set -1, -1 to the major minor values so that it will essentially listen for any beacon that has this UUID. Okay, we're still using the same events. Let's go ahead and take a look at that. So the initial state still is routed through the same function as is the proximity event, but the logic for that update proximity event is a little bit different. First, we switch on the proximity and we determine what kind of a proximity event occurred. If it's an immediate, the idea here is we want to turn the light green and unlock a door. But before we do that, we want to qualify that that minor value is known. Here I'm just hard coding the minor value of the beacon to the beacon that I have in my hand. But of course, you could substitute this for much more complicated logic to do a database lookup, something like that. Once that minor value is validated, we just change the color to be green. And then we have a second parameter that we set for the lock REST components. And we set that to 0, which basically means unlock. Then we fire that lock execution off. And if it's either near or far or away, we just basically are going to do the opposite of that. We're going to lock the door, and then we're going to set the hue iris color to a red color. And lastly, let's see here. Yeah, so basically after that, it's kind of just basically very straightforward. We set the initial state for the light by turning it on. Transition time just means that the light will cycle quickly, and we just set an initial color value of blue. That's pretty much it. So, I really tried to keep this demo as simple as possible just to demonstrate this point. So let's go ahead and fire off the demo and see what it looks like.
Okay.
Before we get to the QA, I'd like to leave you with one final thought, which is to compare beacons with RFID or NFC solutions. But of course, the nice thing about beacons is that you get the range of Bluetooth. Okay, well, I hope you've enjoyed today's session. We look forward to seeing you in the next series of skill sprints, which again, we will be having information about in the near future. I hope you have a great day, and we will now turn it over to Q&A.